Hello everyone, you are welcome to today's class. Our topic today is triangle law of forces. In our last lesson on addition of vectors, we treated inclined vectors using the parallelogram method. Today, we will be taking the triangle method to solve for addition of vectors. The law of the triangle of forces states that if two forces acting on a body are represented by the two sides of a triangle taken in order, the resultant force is represented by the third side of the triangle taken in the opposite order. Using the triangle method, in most cases, there are two forces acting on a body. The third force should balance the other two for the body to be in equilibrium. These three forces acting on the body, if put together, maintaining their direction, will form a closed triangle. If you are given any diagram, carefully analyze it. Identify the forces, their magnitude, and their direction. Carefully put them together in order to form a closed triangle, meaning their resultant is 0. Once the triangle is formed, use trigonometry ratio, sine rule, or Pythagorean's theorem to calculate the unknown magnitude or angles. So now we are going to be taking example. Example 1. A body of mass m equal to 0.5 kilogram is suspended by a string and pulled by a horizontal force of 12 Newton as shown in the diagram. Calculate the tension T in the string if the body is in equilibrium. Take G as 10 meter per second square. Looking at the diagram there, we have the tension T hanging from the ceiling. The body is pulled with 12 Newton, another horizontal force, and the weight of that body is acting directly downward, which is represented by mg. And we are given m as 0.5 kilogram. We will convert 0.5 kilogram to Newton by multiplying by 10, and we'll get 5 Newton. Now we want to form the triangle. We will take the vertical 5 Newton, place it there carefully, still vertical. We take the horizontal 12 Newton, place it carefully there, it is still 12 Newton. Then we take our tension T, use it to close it up as our hypotenuse. Now we have a right angle triangle. We are now going to use Pythagorean's formula to solve for it, which is z squared is equal to x squared plus y squared. Our T is our z. So we will write T squared is equal to 5 squared plus 12 squared. 5 times 5 we get 25. 12 times 12 we get 144. 25 plus 144 will give us 169. T squared is equal to 169. Therefore, T will now be equal to 13 Newton by finding the square root of both sides. Our answer is 13 Newton. Example 2. The diagram above illustrates three forces T1, T2, and 100 Newton in equilibrium. Determine the magnitude of T1. Looking at the diagram, we have 100 Newton acting directly downwards, which is the weight of the body. We have T2 suspended from a ceiling and T1 horizontally. If you look at that diagram, 100 is acting directly downward. We can shift it up a little. Then we use T1 to close it up to form a triangle. What we'll have there is a right angle triangle. If you look at 30 degrees, the opposite of 30 degrees is T1. The adjacent of 30 degrees is 100. The relationship between adjacent and opposite is tan theta. Tan theta is equal to opposite over adjacent. So using that formula, we are going to have tan 30 degrees is equal to T1 over 100. When you cross multiply, you have T1 is equal to tan 30 degrees times 100. Tan 30 degrees is 0.5774. When you multiply by 100, you get 57.74, which is our final answer. Example 3. Two strings, each inclined at an angle 30 degrees to the horizontal, are used to hold a bucket of water weighing 20 Newton. Calculate the tension in each string. 2015. What you do, you are not given the diagram in this case. So you carefully draw out the diagram to understand what the question is. We'll draw a bucket of water. This bucket of water, the weight of this bucket of water is acting directly downwards, 20 Newton. We have two strings attached to the handle of the bucket. These two strings form 30 degrees each to the horizontal. Now, to draw this diagram, we need to form our triangle. 20 Newton, which is acting directly downwards, a vertical line, we'll take it and place it here carefully. We'll take the first string that forms 30 degrees to the horizontal. When we place it there carefully, if it's forming 30 degrees to the horizontal, that means vertically it will form 60 degrees. So vertically we'll have 60 degrees. The second string, the same thing is applicable to it. If we have this triangle, what we are going to use to solve for this triangle now is sine rule, which is A divided by sine A is equal to B divided by sine B, which is equal to C divided by sine C. Substituting for A is 20 Newton divided by sine 60, which will be equal to B divided by sine 60. When we cross multiply, we have B sine 60 degrees is equal to 20 sine 60 degrees. We divide both sides by sine 60 degrees. We will now have B is equal to 20 Newton. If B is 20 Newton, definitely C will also be 20 Newton. Scale drawing method can also be used to solve for triangle of forces. It is advisable you sketch your triangle first. After sketching the triangle, just like what we did with parallelogram method of vectors, you are going to choose a suitable scale. After choosing the suitable scale, you will draw according to the magnitude and direction. Then you measure the third side of the triangle that you are looking for. You convert back to Newton and you have your answer. I hope you enjoyed this lesson. If you have any question, do not forget to drop them at the comment section below and I will respond to them as soon as possible. Do not forget to subscribe too. Bye.